Catching on to what we're doing over here, we're streamlining the process to use just one application at this point. X is a variable, and f of x is equal to x4 minus 6x squared. We're expecting to get 4 roots, by the way. Squared, right? Plus 11x plus 21. And what I'm going to do is plot it. Plot f of x. And I'm expecting to see a 4-3 polynomial plotted out. And I'm really not seeing that. So my question is, I wonder why. Let's take a look. Say I type it in right. x4 minus 6x squared, 11x plus 21. Well, you know what? I gotta do a different plot now. I'm not seeing what I want to see, which is the 4-3 polynomial. And I'm going to do the x min equals minus 10. I'm just using the default that most people use because it's typical of graph paper to have 10 spaces in both directions. And I'm getting a better picture. But I notice it's very flat around here. So what I'm going to do is, you could zoom in, but I'm gonna just change the range of it now. And that's the y values. So let's do that. Let's do y min. I don't know, let's do minus 10. And let's do y max to be 10. Wait a second. Let me go backwards. What happened there? I wasn't expecting to see that. All right. I want to look at those two, right? Kind of remarkable, isn't it? That this and this. Let me go back and look at that again, all right? I'm seeing that. And I'm going to start to change that min-max thing. And I'm going to go to 1,000. Whoops, sorry about that. Let's see, y min equals minus 1,000. Whoops. And don't be confused. The graphs are accurate. They just are deceptive. And that's a really good point, by the way. Okay. I'm getting a better idea now what's happening, right? Looking at these guys over here. And what I mean by that, when you're looking at this over here, I hope you start to realize that there's a dip down here, and then it's going up and it's over here. So I'm getting a better idea, right? Now, this was really deceptive to me. So I'm going to keep moving along. So I'm seeing how this goes to this. And now what I'm going to do, I'm going to continue to restrict the y's. Let me go to that now. So I'm kind of looking at it. Instead of 1,000, I'm going to use the y minimum to be 100 and the y max. And again, I'm not like getting so close to something that I lose what I'm seeing. All right, you want to just approach something slowly. And let me do this over here. And I'm going to say, maybe 100, 200, 200. And I'm hoping that I'm not going in so quick that I'm going to lose sight of what I'm looking for. And I'm seeing it better and better each time. All right, I'm seeing it better and better each time. Now, granted, if you zoom in really close over here, you would see this over here, though. All right, you would see that section over there. And that's what happened when I zoomed in really quickly. So I would say that try to avoid, quick movements. I'm not saying it's wrong to do that, but you might say, oh, that must be wrong. No, it's not wrong. You're just losing too much detail when you zoom in too quickly. All right, so I think I got a good idea about where those roots are now. Let me go back to my Sage, clear. And I'm looking at my picture. And I want to get the roots. And so I want to get these roots over here. And looking at it, I want to point out, it's kind of easy to count. -1, -2, -3. So I'm going to say the first root is between -3 and -2. Whoops. Minus 2.6. You get the idea. I got the answer listed. The other group appears to be between minus 2 and minus 1. Let's put that down. And what do you get there? Yeah, what you expected, all right? So let's repeat. A lot of times people are confused when they get a graph, and then they zoom in so quickly they lose all perspective, all right? It's almost like looking at the Earth from a billion miles away, and then all of a sudden having your face slammed into the Earth a moment later. Boy, you lost a lot of information by doing that. It's nice to zoom in kind of slowly. And that's some of the advantages to using an application like Grapher, which I want to go to briefly. All right. So I'm going to use Grapher. Let me display f of x though first, and I want to go to Grapher. And Grapher is this application that I kind of like. And what are we doing? X4 minus 6x squared plus 11x plus 21. But I notice that students are often confused by software. They're looking at something, gee whiz, what happened there? Well, we just graphed it out. I'm pulling this around. See how much easier it is to pull around, by the way, right? You can also, if you want, you can zoom in. That's not very helpful, though, is it? You can zoom out. You see what I'm doing over there? And I get a better idea. I'm just going to draw a box around, this over here. Maybe zoom out again. Zoom in, zoom out. You get the idea how easy this is to use. Draw a little box again. You get the idea. Also, what's the other idea? The roots. Let's select the equation. And we've done this before. Find root. I'm going to say find root. And the root I want to find is between, I'm going to say it's near minus 3, right? Let me put that down for you. And what numbers to give me? What we expect to say. The other root's near minus 1. I'll put that in for you. What are we getting? What we expect to get, all right? Maybe not the precision that the other software is giving me, but it's not bad, all right? We're getting some pretty good ideas. What's the advantage of Grapher? It really is a nice application to be pulling things around. But again, if you zoom in too much, you're going to certainly lose a lot of detail. And then if you zoom in too quickly, right, you see what I'm doing over there, you might really say, I have no idea what I'm looking at anymore. All right, so be aware of that the zoom features, you can also lose detail if you zoom in too quickly or zoom out too quickly. All right, so that's about it. Thank you.